Hey everyone, welcome back to AI Insights. I'm Fleur Prince, founder of AI Insights, and today we're going to talk all about Final Spark. And I'm here together with Fred Jordan. So, Fred, can you tell me a bit more who you are and what is Final Spark?
Okay, so well, first, thanks for the invitation. It's a pleasure to be there with you. So, who am I? What is Final Spark? So, who am I? I'm a French physicist who came in Switzerland about, I don't know, 30 years ago, 25 years ago, to make a PhD in signal processing, which is basically applied mathematics, and created a first company called Alvision, still running it, and created a second company spin-off called Final Spark. And in Final Spark, what we are trying to do is to build the first bioprocessor. That means a processor where instead of having transistors for computing, we use living human neurons for computing. And that's it.
That's really cool. How did you guys come to this idea to make this?
Well, the basics is that the co-founder and myself, Martin, and me, Fred, we love science fiction.
Mm-hmm.
So this may not be a very good rationale to this question, which is extremely rational, but I have to admit that we love this kind of, I would say, very innovative idea when you do something that people don't expect, these kind of things. And we love this kind of forward thinking. So now, the reason that led us to really go into this direction is first that when we founded Final Spark, the initial goal was already to make, let's say, a revolution in AI. We didn't know which kind of revolution, and we were two where Google was spending billions of dollars on AI. So it didn't look really serious that two of us could do something substantial. So the only chance that we had is to follow very original path, directions of research that the others are not looking at. So this was always one thing. And then there was some luck, pure luck. So one of our employee, so we are six, okay? But at that time we were three, so even smaller. And our first employee, actually, in Switzerland, you have to do your military service. And he had to do it, not in the military, but he was exempted, and he could do it at the Swiss Federal Institute of Technology when I got actually my PhD. And he was more or less forced, okay, to work in a lab, random lab. But this was not that random because this was the lab of Professor Markram, where they are studying human living neurons, biological ones.
Mm-hmm.
And at that time, at Final Spark, we were doing only digital stuff, okay, because I'm a digital guy and Martin also. So we only knew about mathematics and programming. So, and we had this employee who was forced to work here. And at the same time, we were making digital simulations of neurons that were consuming kilowatts of power for a few hundreds of neurons.
Mm-hmm.
So, and at one point, we realized that the power consumption of the human brain, total one, okay, is 20 watts for 100 billion of neurons, okay?
Wait, really? Oh my God,
So
I didn't
then,
know that.
okay, we said to ourselves, as engineer, you have to be rational at some point and recognize when the solution that you are using, it's really not optimal. So when we were consuming kilowatts for a few hundreds of neurons, even not really realistic. And you compare this with the efficiency, about 1 million times more efficient of biological neurons, we just realized that maybe we are not using the right tool. And the right tool would be actually to make a processor with living neurons. This sounded wild, and we loved it for this.
I mean,
Also,
living neurons, that's something you don't hear every day.
yeah.
So, but when I'm looking at the business model, it looks very unique. I mean, you're renting access to a living biocomputer. How did you arrive at this model, and like, what kind of feedback have you received from the research community?
So first, there are two questions here. How did we arrive to this? I would say again, luck. So it's a lot of luck story today. Well, I don't know if it's luck, but there was something called the COVID. Okay,
We all know that.
we all know that. And one of the direct impact of the COVID on our experiments, in our lab, we were having some living neurons and we were interacting with them with electrodes. This is how we work. And at some point the COVID came and we could not come to the lab. Okay, so what we did is that we modified the lab so that we could still do our experiments remotely from home because of the COVID. And we automated more and more things. And at the end of the COVID episode, we could do all experiments entirely from home. Okay? And what happened there is that we realized that if we could do it from home, you could do it from 5,000 kilometers, through internet connection. And we proposed this to universities, and we had many universities that wanted to use our neurons. So we selected finally 10 of them, and now those neurons are used 24/7 by those 10 universities to which we grant free access.
Okay, so it's a pretty much big collaboration then. Is it universities around Europe, or are we talking about like around the world?
Well, potentially it's around the world. In practice, we have some in the US, but most are in Europe. Now, in addition to this, some companies came, and then we said, okay, if you want to have access, then you're going to pay.
Of course, understand.
So we started, but this was the first time we never ever invoiced something at Final Spark. And we said, okay, let's start with $500 a month. Okay, let's see if they accept. And they accepted, and we got more. So we said, okay, that's too many customers. We're going to decrease the number of customers because we have to do something else. We have to do research. So we doubled the price, $1,000, and they kept coming in. So okay, finally we multiplied the price by 10 actually, and today it's $5,000 per month, and we still have customers. So, but it's okay now. So I think at this price, it's fine. And then we have customers even from Japan, so even far away.
There's a high energy consumption of data centers is the core problem you aim to solve. How does Final Spark's biocomputing platform actually fit into the broader conversation of sustainable AI?
Well, quite obviously, in the sense that in AI, most of the time, when people talk about AI, they talk about simulation of neurons. ChatGPT works this way, and most of the AI works this way. Not all AI, okay? And if instead of simulating neurons, you use real neurons, okay? Net gain that you would do doing this is maybe 100 times less electricity consumption. Actually, you will come from something which is a problem on the energy side, as you mentioned, to something which is not a problem at all and forever.
Okay. So you're pretty much so there's actually not a high energy consumption when using this product.
Yeah. I said the energy efficiency is about 1 million times better with living neurons. And the performance is actually higher in the sense that the computation performed by neurons is much more sophisticated, because the simulation we use, for instance, in ChatGPT are really, really, really simple. So it consumes much, much less and does much, much more. Okay. So that's the obvious advantage. So imagine that this data center that we were talking about before, imagine that we do this data center with living neurons. Imagine a nervous tissue of 100 meters by 100 meters by 20 centimeters height. Billions and billions and billions of neurons. I could theoretically serve customers all around the world. They wouldn't see the difference. For instance, they would use ChatGPT, for instance. It will run on this biocomputer, let's call it this way. Would do the same job, but it would consume 100 times less electricity. So between the 1 million and 100 times, okay, I factor in all the things, okay, which make the difference between the theoretical energy efficiency and a practical data center running for.
Do you also see any other primary challenges actually of operating a company at the forefront of such like revolutionary and complex field?
Well, there is an obvious drawback of being so on the edge, okay? It's that you're more or less alone. Investors don't know what to think. If you come today and you try to meet investors, say, okay, I'm going to do nuclear fusion, for instance, okay, which is also very much deep tech, okay, or quantum computers, very much deep tech. I would say similar to us, okay, in the ambition and the complexity. But these ideas have been around for the past 20 years, quantum computers and fusion. So it's okay. You can get money. But in our case, it's so new that even investors or governments never heard of these kind of things. So raising money is the main problem that you have when you are, at the
Are you trying to
forefront like
explain
this.
what it is? I mean, I've heard the same story of founders I'm speaking to here in the Netherlands who, like, when they started talking about AI 10 years ago, that everyone was just like looking at them being like, what am I supposed to do with this technology? It sounds great, but it's only a theory and now it's here. And everyone's like rushing, like, oh, this is going to be the next unicorn. And you already think, okay, but what's next actually after this? And I really much feel like this is what's next.
Yeah, I feel exactly the same. This is what's next. Hopefully, we became a bit viral. So there is at least one very good thing about being viral is that you are approached by many, many people.
Mm-hmm.
And a question of luck, again. Among those people, there are some visionary organizations which are wealthy enough to finance such projects. Okay. So I think we're going to get the investment that we're looking at. Initially, we're looking at 10 millions, but I think we're going to jump directly to 50 millions and to have the second one at 300 million, which is pure science fiction. Okay, normally in the field of deep tech. Okay, but I think this is the kind of investment that we need if we really want to make this bio data center.
Yeah, no, exactly. And I think also, yeah, to make it work, because I do, but maybe we can jump more into the technology that you guys actually, so the okay, I'm going to hope to say it right, the neuro platform. Can you explain in more detail also what a brain, okay, I hope saying this right, a brain organoid is and how it's grown from stem cells in your lab?
Okay, we received so first about the stem cells.
Yeah.
So we get the stem cells. You order it to supplier, okay?
Mm-hmm.
But I explain how the stem cells are done, okay? Basically, they are done not by us, by other labs. So they take cells of the skin, okay, of a human skin, and they are able to transform them into stem cells. These are called induced pluripotent stem cells.
Yes.
Invented by Professor Yamanaka. And from this one, we're able to transform them into any cells. We could do bones, hairs, whatever. In our case, of course, we do neurons.
Yeah. The light version of it.
So, and then it's in the course of several months, we are going to be able to make millions and millions of neurons. And we're going to be able not only to multiply them,
Mm-hmm.
but also to connect them. And we create small balls. And these balls are going to be like 0.5 millimeter to up to 5 millimeter in diameter.
Mm-hmm.
And this is actually human nervous tissue. And we just have then to put them on electrodes,
Mm-hmm.
and we use the electrodes to read the activity or to send some stimulation. So basically, we have a discussion.
That sounds so futuristic. I feel like I'm watching like an episode of Big Bang Theory. As the way you're explaining it. I've like when I've read a few papers on this just to also get into the topic, and it's always felt very theorized. But now you're saying you actually made it practical,
Yeah,
or brought it into reality.
yeah, absolutely. The thing also, but at Final Spark, what we love to do is to do everything. Okay, so we do the algorithms, but we do also the cell culture. We do also the connections with the electrodes, the electronics, the micro.
Mm-hmm.
We do everything. So we understand. But if you look at the paper, it was published in last year in Frontiers.
Mm-hmm.
So you just Google Final Spark Frontiers, or for the listeners, you can see exactly the setup that we are using on all details. And in essence, I mean, it's not that complicated. Well, it's complicated, but this is just engineering, I would say. Okay.
No, but I think it's also very interesting for everyone who's listening to this podcast to know more about this, because, like I said, this really feels like this is going to be the next step. But maybe we can also dive into like how do you actually bridge the gap between biological neural activity and a digital computer? Because like what specific hardware and software are involved in making the I hope I'm saying this right, the wetware and the hardware communicate?
So fundamentally, the technology behind has been available for the past 40 years. Just to answer your question, okay, precise, okay, interface, okay. Because what do you really need? If you take the activity of a neuron, it's electricity. So you are going to have a probe, you measure electricity, then you convert it from a voltage to a value. You do this with analog to digital converters that have been around for half a century. Very simple. And the other way around, if you want to send a stimulation, you want to have a number in your computer and send it to the brain organoid. So what you do is the opposite, is a digital to analog converter, which is going to convert your number into a signal that you can really plug on the electrodes into the brain organoid. And that's it. So the interface is very simple at the hardware and electronic level at this stage. What becomes very much more complicated is which information do you send to your signals? Because you can stimulate all electrodes when you want with many parameters. And how do you interpret the answer of the brain organoid? Because she's going to answer. Sometimes she's not going to answer. Okay? But if she answers, then you have to interpret this. This is where lies the complexity. But the good thing is that we are in digital field again. Okay, so I feel at home. So
That's supposed to be it anyways, I'm just saying.
no, but you can do signal processing and things like this. You can actually even use, and we use it, artificial neural network to make a layer between what you want the brain organoid to do and what you send to the brain organoid. And the layer can be done with artificial neural networks. So this gets a bit more abstract because the brain organoid is basically a biological neural network that you interface with an artificial neural network that you interface with your source code. Okay, so you have basically two black boxes communicating together.
Exactly, to create something beautiful. No, but it's very interesting that you guys, like, for me, it also feels like the way you're explaining is pretty much like a living computer. I think that's actually how you guys also sell it.
Yeah, this is an expression that we give because it very much condenses the whole idea in just 2 words.
No, exactly. I think that also goes good then to my final question, is actually what are the key technical barriers you need to overcome to achieve like your long-term goal of creating artificial general intelligence with this technology?
Artificial general intelligence is, I don't know how to go to that, but I think that biocomputing is probably the best way, the most promising, for an obvious reason. We and you have general intelligence. Therefore, the most conservative way to replicate this is to use actually living neurons, what we have in our own brain. So it's a very conservative approach, okay? But I would tell you the first step that we have to successfully achieve is to train those neurons to do something. Because what I didn't say so far is that once we have all these neurons connected in our brain organoid, they are connected randomly. Okay. And if you connect randomly neurons, I can promise you, if you give an input, you're going to get a random answer. There is no reason why it's going to be meaningful. Okay. So what you need is training. How do you train biological neurons? This nobody really knows. And this is the heart of the topic of research. And I want to add something here, very fun, because I just presented this at Ulster University just on Monday. Okay, our last result of last week, very brand new. Okay, very hot. So I tell you,
Share.
I told you before that basically we need to interact, okay, in a smart way to send the right information and interpret the information coming from them. Normally, we do this by Python programming, where we use our brain just to imagine the best way to communicate. But there is a new way to write software, which I'm sure you know. It's to use LLM.
Yeah, easier.
So what we did last week is that we gave the control to AI agent to interact directly with the brain organoid. So now we have AI agents which are able to write their own software in order to train the neurons successfully. That means it's like experimental research done by AI. It's very, very disruptive. And of course, it's not only in my field of biocomputing that it happens in every field. But in our case, it's mind-blowing, the result that we get.
No. Yeah, okay, I was right. This is the next step. Where you just talking about. No, but this is really cool, especially what you guys do. Maybe this is also a good question then to round also our interview off, is what do you see next happening with Final Spark? Like, where do you see you guys go with this?
Well, there is a question of money here, okay? I cannot answer to this without talking about money, okay? So next step is going to happen is that we are going to raise 50 million, okay? Not even 10, okay? Directly 50. And we are going to hire many people around the world. And we are going to pursue in parallel different paths to master training. And then we're going to scale this to make the first bio server, bio cloud computing, if you want. this is what's going to happen in the following 10 years.
This is really cool. All right. Then, yeah, I think, yeah, definitely. Because I've heard of cloud computing. I know this other company that's called Leap Cloud, where they really say, like, okay, if you want to be sustainable and you want to prove security, cloud computing isn't that thing. But you're going full into bio cloud computing. Nice. Well, thanks so much for us talking about the future vision of Final Spark. I think it's really awesome what you guys are doing. I definitely recommend everyone who's listening read the paper that Fred recommended earlier.
You can also come to the Discord server. If you come to the website, there is a link to a Discord server where people can ask questions, which is always better to ask on the Discord than to ask me or the other employees, because we are overwhelmed with questions, and then it's better for the community that we answer here.
Okay, so everyone, you can even join their Discord. They have a Discord. Important to know. All right. Well, thank you so much for sharing what you guys are doing and joining us all the way from Switzerland. So everyone, as you know, Insights is around the world. Please follow them. I think you guys are on LinkedIn, YouTube, and I think even had an Instagram page. Follow them. I will put all the links in our LinkedIn post and on Spotify and wherever else we are. And thank you for joining, and talk to you all next time.
Thank you. It was a pleasure.